Hello everyone, welcome to Network Jungle for CCNA routing and switching. Let's begin. Today we will discuss about the multi-area OSPF. So OSPF is an important topic in network field. Why we go to the multi-area OSPF? For example, in large scale network, a single area OSPF cannot be used for a large routing tables and it looks burden. By overcome the routing table information using multi-area OSPF. There are several key benefits of the multi-area OSPF. One is the reduced routing table. So reduced routing table. Next one is the improved convergence. That is, if the any topology changes in the topology, it will take within the seconds. It can be updated in the database. That is the improved convergence. Third one, scalability. We can add more topologies in the OSPF concept. Fourth one, enhanced security. So these are the key benefits of the multi-area OSPF. Once again, so reduce routing tables. By limiting the scope of the routing information to individual areas, routers only need to maintain the knowledge of their local area and backbone area. Improved convergence. With a smaller LSDB, router can process update more quickly, leading to faster convergence after the network changes. Scalability. Multi-area OSPF can handle large network with thousands of routers efficiently. Then, enhanced security. By isolating area, you can limit the impact of the potential security breaches. Next, router. So there are different zones. I draw the color. This is the area 0. So this is the area 0. This is the area 1. This is the area 2. So green color I draw the routers. You can see the multiple area 0, area 1, area 2. So between the area 0 and area 1 is connected by some router, as well as the area 0 and area 2 is connected by the some routers. Here, area 0 is the backbone of the OSPF. The central area connecting all the areas, other connecting areas. Then this is the area border router. It's simply called ABR. By connecting the two different areas, it is connected the area 0 and area 1. Likewise, ABR. It is connected between the area 1, area 0 and 2. Here 0 and 1. It carries the LSA informations between the areas. Next one, non-backbone area. So except area 0, all the areas is non-backbone area. Router in a non-backbone area only need to about the routes within the area and the backbone area. Backbone area is nothing but area 0. ABR summarize routes from the area and inject them into the backbone. Next one, area border router. It connects the two or more areas, maintain the LS link state database for each area it belongs to it. It summarizes the routes from the non-backbone area and injects into the backbone area. This is the non-backbone area. It taken the routes from the non-backbone and injects into the backbone area. And last one is the ASBR router. ASBR router is nothing but it connects the OSPF domain to external routing domain. So dynamic routing protocol having the n number of protocol like EGRP, RIP, then default static route. These are the protocols are available. So it can convert from OSPF to external routing domain. That is another routing protocol. It can summarize the external routes and inject them into the OSPF domain. Next one is the key concept. LSDB. So LSDB is nothing but linked state database. Linked state database means each area maintaining the own LSDB. It contains the link and network information within the area. Link and network within the area. Next one is the LSA. LSA is nothing but link state advertisements. It can advertise the information to provide routing information within the area. Link state advertisement. Next one is the summary LSA. Summary LSA is nothing but ABI router create LSA to represent routes from their non-backbone area to backbone area. It can advertise the summary LSA. It can pass the information from non-backbone area to backbone area. Then last, it is using the ABI router. Then next one is the inter-area routing. It provides the hierarchical routing protocol due to route traffic between the different areas. It's simply called IOA in the routing table. Inter OSPF area. LSA is nothing but link state advertisement between the routers. So it having the different LSA types. LSA 1, LSA 2, LSA 3, LSA 4, LSA 5, LSA 6, LSA 7. I can explain one by one. What is LSA 1? So it is the routing information across within the same area. It is having the router LSA. Same area. This is also same area, but it is called network LSA. It have the information, network informations. Next one is the ABR. ABR means summary LSA. It can connect it between the different areas. It can pass the information non-backbone area to backbone area. This is the routing protocol ID O IA. Then fifth one, this is the ASBI router, autonomous system boundary router. It connected from the different protocols, that is the between OSPF and non-OSPF protocols. It can be identify E OSPF external network 1 or OE2. LSA 6 and 7 we can see in the successive class. LSA 1 is it remain the same area. It called router LSA. Then LSA 2 is the same area with destinator routers. Then LSA 3 is the type process in between the ABR. ABR is the area border router. Any router which participates different area is called area border router. Then last one is the autonomous system boundary router. It communicates between the different protocols between the OSPF and non-OSPF protocols. I hope you can know the concept of the what is the different area, ABR, then ASBR, and different areas, then different key concept LSDB, link state advertisement, then summary LSA, then inter area routing, and there are different type of LSA packets, LSA 1, 2, same area. This is the same area. This is the LSA 3. Then this is the LSA 5. Let's see the real-time packet tracer example, and you know the concept very well. Here I am using this topology. So this is the area 0. This is the area 1. This is the area 2. This is the area border router for connecting the backbone area and non-backbone area. So the backbone, area. Non-backbone area. I need to use the different subnets. 192.168.1.0/24, 192.168.2.0/24, 192.168.3.0/24, 172.16.1.0/24, 172.16.2.0/24, 172.16.3.0/24, 10.10.10.0/24. Here the router between the two different area networks. So now we connected the end devices for the networks. Now I use the top down, bottom to top approach. I need to connect switch. So end device is connected to any one of the ports. First Ethernet, you need to connect any one of the switch. Gigabit Ethernet. Yeah, between the routers you need to connect the serial port cables. Before that we need to turn off the router add the serial interface card in every router. Don't forget to turn on the routers. First I need to configure the IP address to the interfaces standard 3 followed by submask standard 1. Here 192 3.0 network 192 168.3.3 192 168.3.1. Mostly cover the different classes of area IP 172.16.3.3 followed by submask the gateway. Gateway is nothing but the router IP address. Go to the serial interface, configure. Instead of CLI, you can see the CLI configuration here. Gigabit Ethernet. Yeah, 0 is connected, 0. Then IP address 10.10.10.1 followed by submask. You can see the interface gigabit Ethernet 0 by 0. Then IP address 10.10.1. By default, class A becomes the /8 subnet. Then we enter the subnet full name. It can update the information /24. Then after that, no shutdown command. Likewise, serial interface. Serial interface is the right side 192.168.10.1 followed by submask. Then turn on the serial interface. You can see the serial command interface serial interface 0/0/0. Then IP address 192.168.10.1 followed by submask and no shutdown command. Likewise, this router. Then in bottom we give the 10.2 here 10.1 here 10.2. Yeah, now this link is up. After that, serial interface. Serial interface having the I give 10.0. Okay. (2.1) followed by submask. I made the mistake 10.1.1 1.2. We need to configure the IP address correctly. Here 10.10.10.1, then 192.168.1.1. Here I was 192.168.1.2 2.1. Gigabit Ethernet 192.168.3.1 followed by submask. Then turn on the interface. Then serial interface is having the left side 192.168.2.1 is configured in the bottom router. Then right side 172.16.1.1 followed by submask. Serial interface 0 172.16.1.2 followed by submask. Yeah, got it. Then serial interface 172.16.2.1 followed by submask. Then turn on the interface. Last outer. Which interface is connected? Serial interface. So 2.1 is configured in the upper router. And gigabit Ethernet. On 172.16.3.1 submask. Now we configure all the IP address. You can cross check by putting the cursor. You can see gigabit Ethernet 0x0 10.10.1/24. Then serial interface 000 having the 192.168.1.1. Here 1.2 for the serial interface 0/0/1. Then serial interface 0/0/92.1. Here 2.2 for serial interface 0/0/1. Then serial interface 0/0/0 172.16.1.1. Gigabit Ethernet 192.168.3.1. Likewise 1.1 for serial interface 1. Then serial interface 0 for 2.1. correct. Likewise 2.2 for the serial interface 1. Gigabit Ethernet 3.1. Now we check. Going to the command prompt, you can reach only up to the gateway 192.168.3.1. yes, 172.16.3. For example 10.10.10.3, it does not about the remote host, so it is where it is available, which area is available, it does not know. So we need to the configuring the dynamic routing protocol using OSPF. Here we going to the multi-area OSPF. We can start from center router, exit router OSPF 1. Before that, best practice is the SOIP route. So what are the networks are directly connected? Here 3 networks. There are 3 interfaces are available. Here the 3 networks are connected. So go to the global configuration mode. After that, router OSPF. This is the autonomous number. Same autonomous number will be used for the interior gateway routing protocol. Then network 172.16.1.0 followed by wildcard mask. 172.16.1.0 wildcard mask. It belongs to the backbone area. By using upper key 192.168.2.0, it belongs to the. So here there are 3 networks are available. One 172.1.0, 2.0, 3.0. It belongs to the OSPF area 0. So that's why we can configure the area 0 3 networks. Next, you can save the configurations. Go to the CLI. Now we configure the left side router. Before that, you need to what are the interfaces networks are connected. Here in the bottom side having the 1.0, then upper side having the 2.0. Configure terminal router OSPF 1 network 192.168.2.0 followed by submask, then area 0. Here area 0 is the backbone area. Now it started the agency. You can see the message. The neighbor route is the 3.1. Next, network 192.168.1.0 followed by submask. Here you need to configure correctly. It is the area border router. In the bottom side having the area 1. Now it is having the two interfaces directly connected networks 10.10.10.0, then 192.168.1.0. Go to the config terminal router OSPF 1 network 10.10.10.0 followed by submask. Area belongs to non-backbone area, that is the 1. Then network 192.168.1.0. So after this command, the adjacency table will be formed. That's when OSPF table. You can see 1, 2, 3, 4, 5, 6, 7. Yeah. You can see the routing table. OSPF protocols. Likewise, we need to configure right side also. So IP route, two networks are directly connected. Go to the global configuration mode. Router OSPF 1 network 172.16.1.0 followed by submask, then area 0, area 1. You can see the area. So it can update the inter-area router. Inter-area routing is the here area border router. OSPF protocol is the 2.0, then 3.0. Likewise, we need to configure this router also. Configure terminal router. Before that, go to the what are the networks are directly connected. Here 2.0, 3.0. Go to the global configuration mode. Router OSPF 1 network 172.16.2.0 followed by submask, area. Both the area will be 2 172.16.3.0 followed by area 2. I wrongly configured the area 1 here. Config terminal router OSPF 1. The command no means remove the command. area 2. Yeah, save the configuration. W. Now we check the routing tables. So how many networks are available? 1, 2, 3, 4, 5, 6, 7. We can see the routing tables in the center router. First network 1, then 192.168.2.0, it is the here, then 192.2.0 directly connected, 3.0 directly connected, then 1.0, it is the directly connected. Here another one networks 172.68. You can see the concept. So this is the first network here, first network. Then 172.16.2.0 is the fifth network directly connected. 2.0, it is the sixth network. 7.0 is the another network. Here 1.0 is the second network. 2.0 is the third network. Then you can see the all the routes are gettings. You can see the different between different area. It can represents the OIA, that is the OSPF inter area routing. 2.0 also having a different area network. 3.0 also having a different area network. 1.0. There are 4 different area networks. Likewise, we need to check all the routers. If the routing table is not updated in the router, it is having some issue on the routing tables or configurations. Here 2 networks are directly connected, so 5 networks are getting the OSPF inter area networks 1.0, 2.0, 3.0. Now we check the ping. First time it can get filled 172.16.3.3. Yeah, we got the routes. Now we check from the end devices. Ping 172.16.3.3. You can see the destination reachable likewise in this device. So initially it got failed. Yeah, super. Some of the verification comments. So IP protocols. So IP protocols, it is the OSPF autonomous number 1. So there is no incoming outgoing filter. Here it is the 3 interface gateway interface 2.1, then 2.1, 3.1. So which one having the highest IP address, it becomes the router ID. Number of areas in the router 1. Then routing networks are 1.0, 2.0, 3.0. It belongs to the all the areas are 0. It is the last update from the neighbor informations. By default, this is the OSPF AD value. So IP OSPF. So OSPF, this is the autonomous value, router ID, then support LSA. Backbone area. Number of interfaces 3. So there is no authentication. If we need, we can need the authentication. So which algorithm to calculate the best path? Using the SPF, shortest path algorithm. Number of LSA is the 7 networks. So IP OSPF database. So IP OSPF database. So IP OSPF database router ID. Here link ID, that is the router LSA. It can communicate within the area. So that's the network's ID 192.168.2.1, 3.1, then 2.1. Here 1.0, 10.0. So it can advertise which interface, that is the 2.1. 2.1 is the directly connected network. From that interface it gets the informations. As well as here, just a minute, just 2 seconds. Here this network it going via which interface? 2.1, that is the 2.1. As well as here 2.1 and 3.1 is available. So it going 1.1. That's why it can show the adjacency neighbor routing table. That is, I already told, LSA3. LSA3 can advertise the summary LSA between the routers. So IP OSPF neighbors. For the center router, it has the two adjacency. Here 2.1 and 172.16.2.1. It is the state is full. It is the dead time. Then neighbor interface. Then which serial numbers? Which interface? Serial interface 0/0/1. Then serial interface 0/0/0. You can segregate routing tables. So what are the networks are updated via OSPF? You can see the routing table informations. File networks. Here also, so IP route OSPF. So directly connected networks are 2. Then it can update the routing information from OSPF via 5 networks. I hope you can understand the concept using multi-area OSPF. Thanks for watching video. Please like and subscribe the Network Jungle. Thank you.